Hi everyone! This week's requested topic is hypothesis testing. How to solve the problems, how to read through all those words and figure out what you have to do, how to perform the specific tests, and everything else associated with hypothesis testing. So I'm going to make a little series of videos about hypothesis testing and how all it works. And I want to start off by saying I did not get hypothesis testing for years. So if you are sitting there thinking, I don't get hypothesis testing, I am so stupid, I cannot figure this out, I have no idea what's wrong, everybody else gets it. Actually, no. People have a really, really hard time with statistics in general. The human brain is just not really set up to grab statistics the first time you see it. You have to do it over and over and over again and practice a whole bunch, and then eventually it will click. And so for me, it didn't click in undergraduate. It didn't click in the first grad stat class I took. It didn't click in the second grad stat class I took. And it didn't click in the third grad stat class I took. And in fact, when I was teaching this class for the first time, going in, I did not understand hypothesis testing completely. It wasn't until I was about a week away from having to teach hypothesis testing where I sat down with this and said, okay, I have got to teach this to my students next week. I need to figure this out. So I did. I sat down and I stared at it, and my brain suddenly flipped itself upside down and then right side back up, and I went, oh wait, okay, I get it. Okay, I got this. And I was able to teach it. So if you're struggling with hypothesis testing, you're not alone. So keep at it. Don't give up. Please feel free to ask for help if you need it. And hopefully going through the homework and these videos and the other content on Blackboard will help you sort of straighten things out. One of the hardest parts about hypothesis testing is translating that huge block of text that you're given in terms of your problem into something that is a manageable formula. So let's go through a couple of hypothesis testing problems and see how all of that text does get translated into formulas. Here we have some hypothesis testing problems. Just as a note, all of these problems are completely solvable, so if you would like to practice hypothesis testing, feel free to use these problems as practice problems. Let's look at the first problem. As we go through each problem, I'm going to highlight the information that we need to know in order to solve the problem. So in this first problem, we have a laboratory scale. We've got a standard weight that we're weighing. We know that standard weight is supposed to weigh 1 gram. We weigh 4 times on the scale, we get measurements, and we want to know, is the scale properly calibrated? And you might be thinking, well, how is that even a hypothesis test? There's nothing about hypothesis in here. It didn't mention anything. Well, we want to know if that scale is properly calibrated. And if it's properly calibrated, it should be close to or equal to 1 gram in weight for this weight. Every time you weigh that weight, it should come up as 1 gram. Obviously, it doesn't, because we've got a variation in our weights, but we want to know if that variation in weights is small enough that we can consider the scale calibrated in that it's reading, on average, that weight is 1 gram. So we are performing a hypothesis test here, and we want to know, is the scale weighing this weight at 1 gram or not? And it's the or not that tells us how many tails we need in our test. So if we wanted to know that if it was weighing greater than 1 gram, that's a one-tailed or a one-sided test. We want to know, is this thing weighing 1 gram or not? So we're measuring less than and greater than in our particular test. We want to make sure it's as close to 1 as possible. So that's why we're using a two-tailed test. Now, in terms of what we're testing, we have this measurement here. It's supposed to be 1 gram. So let's highlight that. That's what the weight is supposed to be. Now we have 4 weights here, and we can get an average off of those 4 weights. So what we're doing is comparing that average 4 weights to what our weight is supposed to be. And since we are comparing an average or a mean, we are doing a hypothesis test on one mean. We are comparing it to something it is supposed to be. So we only have one sample mean that we are comparing. And you may be saying, wait a minute, what about the standard deviation? Where is that in this problem? Well, you're going to have to calculate it because you're given those 4 weights. You can calculate the standard deviation of these 4 weights, and that is your sample standard deviation. You're not given a population standard deviation. That is unknown. So you're doing a hypothesis test on a mean, variance unknown, and it's a 2-tailed test. So that means that you're going to have to use the t-distribution to do this because your variance is not known. So you're going to compare your means using that t-distribution. So there's our first problem. Let's take a look at this second problem. We've got 2 bake ovens, and the baker thinks that one oven is hotter than the other. So she takes temperature readings and compares the 2 temperature readings. We have oven 1 with this average temperature and this standard deviation. We have oven 2 with this average temperature and this standard deviation. So those are our data for our 2 different ovens. And we want to find out, is the baker correct that one oven is hotter than the other? All right, so first thing, we've got an average here, sample average here, and we are comparing it to another sample average. Now, since we are comparing one sample average against a second sample average, we're not comparing anything to a true value. We've got a hypothesis test on 2 means. So that's where that comes from. Now, when we have a hypothesis test on 2 means, we have to worry about our variance. Our variance is either known or unknown. Now, this problem does not give you any information on the true variance or the population variance of the temperatures in these ovens. So our population variance is unknown. Now, we're not given any information that we can assume that those population variances are the same thing. So we're going to have to make the assumption that they are not. That is the safer assumption to make. So we're doing a hypothesis test on 2 means, variances unknown and unequal. So we're going to have to use our sample standard deviation, convert it to variance by squaring it, because that's the way you convert standard deviation to variance, and then use that particular equation for unknown, unequal variances to do this hypothesis test. In terms of comparison, we want to find out whether one oven is hotter than the other. So we want to find out if one mean, one sample average is greater than the other. And so since we're concerned with greater than, that's a one-sided test. If we were thinking about, are these oven temperatures equal, that would be a 2-sided test because you can be greater than or less than. But we're only concerned with, is one oven hotter than the other, and that's a greater than, so that's a one-tailed test. When you're doing this comparison, you don't have any population statistics, so just like that first example, since we don't have our population statistics, we have to use the t-distribution for comparison. So that is our second problem. Let's take a look at our third problem. We've got a French fry manufacturer and they're making steak fries and they're worried that the width is varying too much. So they take a sample, they know that they have a variance that they are looking for. They don't want it to be any higher than 5 millimeters, and they sample 40 fries, and then they show the variance in that sample is 11 millimeters. And we want to know, should they be concerned about the variance in fry width? So, a lot of people, because they get really used to testing hypotheses on means, they'll go, okay, means, where's my mean? Oh, average. Okay, my average is 11. No, that's your average variance. Be very, very careful when you read these problems. Make sure you are reading them very clearly. So you take the sample, you're calculating variance, and your variance is 11 millimeters. So you are comparing that to another variance. Therefore, you are doing a hypothesis test on the variance, not on the mean. When you do that, you have a variance that you want this compared to. So you are doing a hypothesis test on one variance because you have one sample and you're testing that sample variance against a value you want. So hypothesis test on one variance. So that means you're going to use the chi-square distribution. As you read that last sentence, you're thinking, well, what does be concerned mean? What is this? Does that mean, is it equal? Is it not equal? Greater than? Less than? What is this? If you look back in the problem here, we want the variance in diameter to be no more than 5 millimeters. So that means our variance needs to be 5 millimeters or less. And that means further that we have this average variance right here that we're comparing against our intended variance, and we want to know, is that variance truly greater than 5 millimeters? So we are doing a one-sided test because we are concerned with greater than. We don't care if it's less than 5 millimeters, and in fact, we know it's not less than 5 millimeters because we're looking at 11. So we want to know, is that 11 actually statistically different than 5 based on our sample size of 40? So we are doing a one-sided test because we're just concerned with greater than. And that is problem 3. Here is our fourth problem. So I will pause for a second. Feel free to pause the video. Take a look at this problem and see, what are we doing a hypothesis test on? What equation do we need to use? And should we be doing a one-tailed or a two-tailed test? All right, let's take a look at this. We've got 2 candy machines, and they are producing candies. And they should be producing candies with a weight of 15 grams and a standard deviation of 0.3 grams. So that's what they should be doing. Now, we have a QA tech. They took 5 samples from each machine, and they figured out, okay, so machine 1 is giving us candies with this weight, and machine 2 is giving us candies with a different weight. And so we want to figure out, okay, is machine 1 producing candies with a greater weight than machine 2? Let's break this down. First off, we have 2 machines. We have 2 samples. We are comparing our samples against each other. Therefore, we are doing a hypothesis test on 2 means, 2 sample means. So we have a population standard deviation here. We can use that population standard deviation in our hypothesis test. So that means we are doing a hypothesis test on 2 means, variance known, which is awesome because that means we can use the z distribution. Okay. Now we have to figure out how we're going to compare them to each other. So we're going to compare machine 1 to machine 2, and we're going to do a one-tailed test because we're being asked, does the QA tech have reason to believe that machine 1 is producing candies with greater weight than machine 2? So we're only concerned with candies that have greater weight. We don't care if they have lesser weight. We're only looking at one side, greater than. So that means that we're doing a one-sided hypothesis test. And that's problem 4. Let's take a look at problem 5. We'll pause again. Try to figure out what hypothesis test you need, what distribution, how many tails. All right. So we've got a snack manufacturer working to reduce quality defects in sandwich cookies. And they start some quality improvements. So before the quality improvements, 7.5 of their cookies were defective. After the quality improvements, they take another sample, and they found, hey, it's dropped to 6%. All right. Have they significantly improved their cookie quality? Well, this one, we're talking about percent of a population. And so we are going to do a hypothesis test on a population proportion, because that population, each individual in that population either has a defect or it doesn't. It's one or the other. And so when you have that either or type option, that means that you're looking at a population proportion. So here was the initial population proportion. That is the standard one that you're looking at. Here is the latest one. So that latest one has dropped, and we want to find out if that is a significant drop. In population proportions, you always use the z-distribution, standard normal distribution. And so in terms of tails, they want to find out if they have significantly improved their cookie quality. And so they want to find out if that 6% is statistically less than 7.5. So we're doing a one-sided test because we are concerned with less than. And there's problem 6. Here's our last problem. Take a minute, figure out what are we testing, what equation do we need, what distribution do we need, how many tails. All right, this problem is about a diet program, and they want to have a certain claim. And they want to claim that the average weight loss is more than 10 pounds in 2 weeks. They've got some data that shows the variance in the weight is 4 pounds. Cool. And so Mike has been on their diet, and he's only lost 5 pounds. And so he wants to know, does he have a reason to complain? He only lost 5 pounds. So what we are doing is a comparison of a single point against a population proportion. And so this actually is a hypothesis test on a mean. It's just a mean with a sample size of 1. And yes, you can technically do that. Your statistical power is horrible, but you can do that. So we do have population variance, so we can use the z-distribution. And we have our population average. There's our 10 pounds. We're comparing it to our tiny sample size of 1 average. And we want to figure out, okay, does he have a reason to file a complaint with the company? Well, he clearly lost less than 10 pounds. So we are trying to figure out if that less than 10 pounds is statistically less than 10 pounds. So we are going to do a one-tailed test because we're only interested in the less than side of things, not the greater than side. If we had been greater than, Mike would not have a problem and he would be completely happy. But he lost less than 10 pounds, so we're going to do a one-tailed test on this. All right, that wraps up hypothesis testing problems and sorting out data. So you can see all the highlight in here with the information of importance to the problem. As you're going through hypothesis testing problems for the course, feel free to grab a highlighter and highlight your own problems. You can do this on the computer. This was done in Preview on Mac with the highlighting option. You can also use Adobe Acrobat Reader to highlight. You can use a highlighting program in Word. You can print things out, use your own highlighter, whatever you want. But having things highlighted helps you look at what's important, and it gets rid of all that extra text that's just there for story and context. So feel free to do that. Make sure you're reading your problems very carefully so you know what you're supposed to be doing a hypothesis test on, you know what distribution to use, and you know how many tails need to be in your test. And as always, feel free to contact me if you have any questions.